Out of This World now on BBC One. It's The Sky at Night with Patrick Moore.
Good evening. Our main theme now, the red world of Mars, now coming nicely into view in the evening sky. And we're getting superb pictures from MGS, Mars Global Surveyor, now going around the planet. Look at this picture of Martian weather, which is quite amazing. But first of all, a fascinating news note I can't possibly leave out. For the first time, an unmanned probe has landed upon the surface of an asteroid. Now, the asteroids are tiny worlds. Most of them keep to the area between the paths of Mars and Jupiter. Only one, Ceres, is as much as 500 miles across. Only one, Vesta, can ever be seen with the naked eye. Most are much smaller. And most of them keep to the main belt. But some don't. Some of them swing inwards and may come close to the Earth. One of these is Eros, discovered way back in 1898. And that can come within 15 million miles of us, as it did in 1975. And plans were made to send a space probe there. The space probe near Earth Asteroid Rendezvous, then named after Gene Shoemaker, the great astronomer. And that was finally sent toward Eros, and as it approached, sent back pictures like this. A strange place, a midget, 29 miles long, 8 miles wide, 8 miles thick, with a very weak pull of gravity. If I went there, I'd weigh only a few ounces. And then, on St. Valentine's Day last year, Near entered the path round Eros and began sending back pictures like that. We can see the rough crater surface. By mid-April, it was within 31 miles of Eros, and look at this picture. Now getting real details there. Came down on 7th of July within 22 miles. Look at that huge pit there with a dark floor. And then 27 October, now we're seeing features only a few feet across. And before long, the entire surface was mapped. But then, why not try and land it? That was not in the original plan, and therefore the chance of success seemed very low, but why not try? Nothing to lose. So a target area selected, near the edge of the plain known as Eros, and then, on February the 12th, the descent began, to try to bring it down on the asteroid surface. And I think very few people thought it would work, but it did. As Near came down, sent back pictures. Here's the last one, tiny features now. And then, amazingly, it came down, apparently undamaged, and began sending back pictures. It stopped transmitting now, it's still there, and it's told us a great deal more about asteroids than we knew. And one thing's important. Some asteroids are more rubble piles. Eros is not. It's what they call a planetesimal. It's solid, composed rather like the meteorites we call chondrites, and therefore it's a pretty solid thing. The chances of our being hit by an asteroid are not very high, but it could happen. The chances are not nil. Therefore, the more we know about asteroids, the better. And Near has told us a great deal, one of the major triumphs of the modern space age. And now, on to our main theme, Mars coming closer to us. It'll be well seen in the summer. And why is Mars so interesting? Well, I think because all we suppose there might be life there. And less than 100 years ago, men like Percival Lowell were drawing canals upon Mars. They believed they were dug by intelligent beings. Well, we now know that's not so. There are no beings there, but is there any life at all? We've heard about the meteorite landing in Antarctica and said by some to have come from Mars. In that have been found tiny crystals of magnetite, less than 1/millionth of an inch across. You see them there, they're arrowed in the bottom picture. In the top picture, the same kind of thing in an earth rock. It's been claimed that these are due to organisms that were once living. Well, I must say, I'm a bit sceptical about this. We'll know before long, I hope. And of course, we now have pictures, first of all from the Hubble telescope, and there's the Hubble picture, and now, above all, from Mars Global Surveyor, which has been an outstanding success. And look at those polar caps and the dark markings there. And MGS has told us more about Mars than we ever knew before. At this stage, welcome back to one of our regular visitors, Dr. Peter Cattermole. Welcome back, Peter.
Thank you.
First of all, can you summarise what MGS has told us?
Simple question, Patrick, difficult to answer. The problem being that it's told us so much that Mars is really a completely different world from the one we thought it was a couple of years ago. But of course the scheme for Mars Global Surveyor was it was going to survey the planet for the whole of 2 years. That's 1 Martian year, 2 Earth years. So we now have a picture of the global weather pattern for the whole of a Martian year. We have mapped at high resolution every part of the surface. We actually know the topography of the surface for the first time, and we know much more about the actual makeup of the surface. And I suppose the obvious place to kick off, because it's so exciting, is with the weather, because you showed that rather splendid Hubble picture. Now here's a Mars Global Surveyor picture, the daily weather picture it's called. And the probe actually goes around Mars 12 times a day, so we have almost as good a weather forecast for Mars as we have for Earth. And the importance of this is, and of course the atmosphere is very important in moving dust around Mars and transporting particles, is that it's allowed us to understand how the atmosphere circulates. And we have a diagram here which shows us our modern view of how the atmosphere of Mars works. The first thing, of course, to remember is there are no oceans and continents on Mars, so things are a little simpler than they are on Earth. But broadly speaking, warm air on Mars rises over whichever is the summer hemisphere and descends over the poles, over the winter hemisphere. And about 30% of all the carbon dioxide that's in the air is actually deposited on whichever is the winter pole. So we have a strong convectional flow from the warm hemisphere to the poles. And then superimposed on that, we have a major circulation in the equatorial region known as a Hadley cell, which is just a great big cell about 30 kilometers deep. And you'll see on the bottom diagram that during summer or winter there's a single Hadley cell that just rises and then falls. The warm air rises and sinks. But in spring and autumn, that is at the equinoxes, the cell breaks into two, and we have a slightly more complicated dual cell. And that's all totally new information.
And of course, MGS can show these tremendous storms.
Well, the storms, of course, are very, very important. There's a lovely picture here of a swirling storm around the North Martian pole. And we now know these are extremely common, particularly at certain parts of a Martian year, certain times. And they, of course, are very important in the movement of dust around and towards the polar regions.
Obviously, the atmosphere is most important, and MGS is also telling us more about the Martian surface.
Oh, indeed it has, Patrick, and that's, in a sense, as a planetary geologist, the bit I'm the most interested and excited in. First of all, I need to just refresh our memories on what was aboard the spacecraft. There wasn't just a camera, the orbiting camera. There was also an instrument known as MOLA, the Mars Orbiting Laser Altimeter, which measured the height of the surface of Mars very accurately to a vertical height of 30 meters. There was a magnetometer for measuring the strength of the magnetic field from place to place, a thermal emission spectrometer which in a sense measured the heat coming from Mars, and in that way was able to tell us something about the surface composition. And then there was a radio experiment which enabled us to discover the distribution of mass or gravity on Mars. And perhaps the most spectacular visually was the results of the MOLA, so this is probably the best place to start. And here is a typical colour-coded MOLA map of the topography of the hemisphere of Mars, in which sits that huge impact basin known as Hellas. Now, low ground is shown in the deepest blue colours and the highest ground in the reds and whites. And you can see the very deep basin of Hellas there towards the southern end of the shot. You can see the high ground, the red and yellow ground of most of the southern hemisphere. You can see that the northern hemisphere is by and large low. It's shown in shades of blue, and you can see in the centre of the shot the impact or the basin known as Isidis, and towards the top right hand corner you can see the area we know as Elysium, a huge volcanic mass. And MOLA has produced a whole series of these wonderful maps. Here is an equatorial projection giving us a wonderful visual impression of what the planet is really like, in a sense giving us a 3D impression. Again, you can see Hellas towards the bottom left. But on the right-hand side of the image, you see that very strong sort of pear-shaped red area of high ground, which is the vast Tharsis bulge, a bulge about 4,000 kilometres across on which sits Mars's highest volcanoes. Yes. And slashing across the eastern side of that, you see the very deep blue-coloured trough of the equatorial canyon system, Valles Marineris. But I suppose the strongest image is that there is a difference between the two hemispheres. A high, that is a red-coloured southern hemisphere, and a low blue-coloured northern. And indeed we have details of the polar caps, the topography of the polar caps for the first time. And here is a shot looking down towards the North Pole in the northern hemisphere, and you can see the greenish area towards 12 o'clock there is in fact the slightly raised region of the North Polar Cap. So we have all this wonderful new information on the shape and the topography of the surface.
The boundary between the high south and the smooth north is very well marked.
It certainly is, and this boundary we know as the line of dichotomy, and in fact Mola helps us here because it actually produces maps of surface roughness, and we have one here, and it shows very clearly that most of the southern hemisphere is extremely rough. The reds and yellows are representative of rough surfaces, the blues of smooth surfaces. And you'll notice that most of Tharsis, you'll be able to identify that in the previous map, is quite rough. And indeed the slash of Valles Marineris you see to the right-hand side of the image, its walls also show up in red colours, it being a very rough area. To the west of Tharsis you see the deepest blue region on that map. That is the region known as Amazonas, a very smooth plain. And again, the roughness picks out the northern hemisphere as a relatively smooth area.
Is there a definite link between slope angle and surface roughness?
There is, and I mean this doesn't come as any great surprise, and Mola is able to measure slopes over a 30-kilometre baseline, and here is a slopes map. And the deep blues again are the smooth areas where slopes are more or less nil, and you can see most of the northern hemisphere is extremely flat indeed. But most of the southern hemisphere, the rough hemisphere, has quite considerable slopes. And just one point that's worth noticing, just north of Tharsis you can see a curving line within the blue tint. And that is an area north of a volcano known as Alba Patera, and that is an area where some planetary scientists have been seeking out whether there's any geomorphological evidence for an ancient shoreline which would indicate something, of course, quite important about the northern hemisphere.
In these NASA maps, the low area are always coloured blue. Is there any particular reason for that?
I think I know what you're driving at, Patrick. I don't think it's a coincidence.
No.
There has, of course, been a lot of discussion about the fact or the possibility that the lowland northern hemisphere may once have been the site of a vast paleo-ocean or a series of lakes. And Mola has been able to show us, and there's a slice through Mars here showing the topography, a topographic slice, has been able to show us something quite important, and that is, and on this diagram to the right we have the elevated southern hemisphere, to the left obviously the north. There is a continual slope down towards the northern plains, and we believe that that shape, if you like, that topography has been in place for several thousands of millions of years. So there would have been a natural tendency for any volatiles or water or whatever it may be to flow from the south towards the north, and therefore if there had ever been any water on Mars it would naturally tend to drain towards the northern lowlands.
Does it always mean that there may be a definite difference between what lies below these two hemispheres?
Yes, and this is of course why on board the spacecraft there was an instrument to measure gravity, because gravity is related to the mass of material that sits beneath the surface of a planet. And we have a very simple global map of gravity here. The western hemisphere on the left, you can see there is shown a strip on the eastern side, the right-hand side of that left hemisphere, which is the Valles Marineris. And this is an area of negative gravity anomaly. That is, there's less than the normal amount of mass you would expect to find. And that's not surprising because it is a huge hole in the Martian crust. And the only other strong features, gravity features, are over Tharsis. You'll see the three Tharsis volcanoes show in dark tones, and indeed Olympus Mons on the extreme left. And the fact that these are able to be there suggests that the crust beneath those areas must be relatively strong and is able to support those great loads on the crust. And so we have learnt something quite significant. There are anomalies, they're few in number, and most of them don't occur in the southern hemisphere.
So the crust thickness is different in the two hemispheres?
Yeah, it is indeed, Patrick. Beneath the northern plains, and we have a cross-section here showing the crustal thickness, which is a combination of molar and the gravity data, you'll see that the northern hemisphere is only about 40 kilometres thick, whereas on the right-hand side, moving towards the south, the crust beneath the southern hemisphere is about 70 kilometres thick. And this has probably been in place for most of Mars's history, and this is quite important because if you think about it, what we seem to have is a thin northern crust which is able to have a considerable strength and therefore support loads, and a rather weak but thick southern crust. And even more significant is if you have a thin northern crust, then it would be able to allow heat from inside Mars to escape relatively readily, and therefore you might have relatively high heat flow quite early on in Mars history from the northern hemisphere that could melt, for instance, ice and generate a relatively dense warm atmosphere. It's purely hypothetical, but it's a possibility.
When the spacecraft was aerobraking toward Mars, it detected a weak but definite magnetic field. Is there any more news on that?
There certainly is. That was a sort of planetary field, a very weak one it discovered, but very, very surprisingly, as the orbit was dropped to within, 200 kilometres of the surface, the magnetometer aboard started picking up some very strange readings, and I have a map here of magnetic field. Now, it's a little bit confusing, but you see it has a north-south grain, and this is representative of the orbit of the spacecrafts because it orbited from north to south. But if you look at the bottom left-hand corner, you'll see a series of blue, deep blue and red and yellow stripes running more or less west to east. And these are representative of positive and negative magnetism. And they form a series of stripes, and these were completely unexpected. And they were certainly unexpected in the southern hemisphere of the planet, which is the old hemisphere, we believe. And the similarity of these stripes to what we call magnetic stripes on the Earth led some scientists to get very excited and say, well, perhaps we had plate tectonics on the Earth. The crust is moving apart. But we have a bit of a problem here because the crust in that area, as we know, is 70 kilometres thick. And if you have a hot slab of crust that thick, it would take an awful long time for it to cool under normal circumstances, in which case it would take an awful long time for the magnetism to be locked in. And so it may imply that when these stripes were formed, the heat flow out of Mars was extremely quick, and it cooled much more quickly than we think. So these are sort of something that people are really scratching their heads about at the present time.
Why do you think there are no magnetic sources underneath the big impact craters such as Hellas and Argyle?
Well, I think the answer is quite simple, Patrick. The magnetic field had died relatively quickly because the planet was losing heat quickly, and therefore it wasn't molten inside, and the impact basins formed after the field had died, so they have no magnetic imprint.
All quite fascinating. Well, next month we'll go into more detail, but for the moment, anything else you want to add now?
I think just one little snippet. I haven't mentioned the thermal emission spectrometer, the thing that effectively measures the thermal band of the electromagnetic spectrum. Now, I have a map here which at first sight looks a little esoteric, but this instrument was able to measure effectively the composition of the surface from place to place. And very recently some of the scientists got very excited because they had discovered an area or areas covered with the mineral olivine, and it's the area shown in blue on that map. Now, this may not seem terribly significant, but olivine is a mineral that forms at very high temperature inside lavas, and I actually have a piece of olivine here. It's a green mineral, and it forms at very high temperature inside a planet, and it doesn't really like to be in the presence of water. So when an olivine crystal on the Earth comes up to the surface and reacts with the Earth's atmosphere, it almost instantly, or over a few millions of years, breaks down into sort of brown material, other minerals that are more stable under the new conditions. Now, the fact that the scientists have pinned olivine down on the surface of Mars in the southern hemisphere suggests that there cannot have been water or an atmosphere of any density at the surface of Mars in the southern hemisphere in recent times. It just cannot have been there, or the olivine wouldn't have been there.
I wonder, can there have been life there that's died out, or can there be any trace of life there now? I wonder. Well, when we come back next month, Peter, we'll go into more detail. Meanwhile, thank you very much indeed. Don't forget our website, www.bbc.co.uk/Sky@Night, or CFAX page 620. And next month we'll go into more detail about what Mars Global Surveyor is telling us. Until then, from Peter and myself, good night.